Okay, so let us see question number 33. Okay, question number 33 is asking what is the benefit of what is the benefit of band pass sampling. Okay, so that is what see here, benefit of benefit benefit of what band pass benefit of band pass sampling benefit of band pass sampling over low pass low pass sampling over low pass sampling. Okay, so benefit of band pass sampling over low pass sampling, what is the benefit? So that is the question about this, question number 33 about this. Okay, so first of all we will see low pass sampling. Okay, so first you see low pass sampling, low pass low pass sampling low pass sampling. First see low pass sampling. About low pass sampling, let us see low pass signal. What low pass signal? What is this low pass signal? First of all, know about this. What is low pass signal? Low pass signals are those signals. Low pass signal are those signals whose center frequency lies at origin. Okay, whose center frequency lies at origin. Okay, the signal which lies around origin. Thus, or you can say the signal which lies around origin is nothing but is known as low pass signal, or the signal whose center frequency lies at origin is known as low pass signal. Okay, so if you see this low pass signal, this is my low pass signal. Okay, so this is what low pass signal. What is the frequency of this? Let us say this is my B. So this is B hertz. This is 0. This is my bandwidth. Bandwidth is what? B. Okay, so this is my negative frequency. Okay, so negative frequency we are not taking in consideration. Okay, so let us take this B. So what is what is bandwidth? B. Okay, so now we are going to see what? Low pass sampling. As we know very well, sampling for low pass signal is what? Low pass signal sampling is nothing but by applying Nyquist criteria. Okay, Nyquist Nyquist rate. Though for low pass signal, the sampling is given by Nyquist rate. Okay, so Nyquist rate, by Nyquist rate, if you see here, let us write Nyquist rate, Nyquist rate. Yes, Nyquist rate, which implies that sampling frequency for low pass signal is nothing but twice the bandwidth of this signal. Okay, twice the bandwidth of low pass signal. So Nyquist rate is nothing but the sampling for Nyquist rate. The sampling frequency is what? Fs is equal to 2b. Fs is equal to 2b. What is this Nyquist rate actually? Actually, as we know very well, when the signal is band limited. Okay, when the signal is band limited to B hertz, when the signal is band limited to B hertz. Okay, B hertz. So then this signal at what? At receiving side, at a reception side, this signal can be reconstructed. Okay, so this signal can be reconstructed properly. This signal can be reconstructed properly without any loss of information. Okay, without any loss of information from their sampled version. Okay, from their sample, only when this signal is sampled at the rate at this signal is sampled at the rate equal to twice of its bandwidth. Okay, so which is known as Nyquist rate. Once again, listen. Whenever the signal is band limited to B hertz, whenever the signal is band limited to B hertz, and this signal can be properly reconstructed at the reception side, from its sample, without any loss of information, without any aliasing problem. Okay, so this signal can be reconstructed where? At receiver side. When when we apply Nyquist rate. Okay, so when we sample this signal at the rate of twice of its bandwidth, at the rate of twice of its bandwidth, that is what bandwidth. Okay, twice the rate of its bandwidth, that is hertz. Okay, so hertz, so fs is equal to twice of bandwidth. So this is my Nyquist rate, and sampling frequency for this, we can say sampling frequency like this is what 2b hertz. Yes, 2b hertz. This is known as what Nyquist rate. Or if you write fs is equal to 2b what sample 2b sample per second, 2b sample per second. So 2b sample per second, that time you can call it as, you can call it as what sampling rate, yes. If you will call it as Nyquist rate, that time you can say hertz, fs is equal to twice 2b hertz. Okay, so when you will say sampling frequency, that is 2b sample per second means every second we are passing, every second we are taking twice of bandwidth. Okay, twice of bandwidth sample per second. So this is what about low pass sampling. This is low pass sampling. If you see for what, for band pass sampling, see here band pass band pass sampling band pass sampling band pass sampling. In band pass sampling, if you see here, what is band pass sampling? First of all, see band pass signal. This is my low pass signal. Here you see band pass signal. Here you just see what? Let us see band pass signal. Here band pass signal. What is band pass signal? What is band pass signal? See, let us see band pass. This is my low pass signal. Okay. What is band pass signal? Band pass signal are those signal whose center frequency lies at non-zero. Okay, whose center frequency is non-zero, whose center lies not at origin. Okay, whose center frequency is non-zero is nothing but what? Is nothing but band pass signal. Or you can say the band pass signal, those signal which lies around non-zero frequency. Okay, which lies around non-zero frequency is known as band pass sampling, or the band pass sampling are band pass signal. Okay, so those are what band pass signal. Band pass signal is what? Band pass signals are those signals whose center frequency is non-zero, or you can say band pass signal are those signal which lies around non-zero frequency. Okay, which lies around non-zero frequency, whose center is non-zero frequency. Okay, whose center lies at non-zero frequency. So this is my band pass signal. If you see here band pass signal, this is what center frequency. So let us say this is my fc plus b. Yes, this is my fc minus b. Okay, if I will modulate this signal, if I will modulate this low pass signal, so then I will get the shifted version of this signal. Okay, at this point which is lies at non-zero, whose center lies at non-zero frequency. Now it is what band pass signal. Okay, band pass signal. Just remember, band pass signal are those signal whose center frequency is non-zero. So this is what f hertz. Okay, so this is my band pass signal. Let us say this is my band pass signal. X of t, band x of f. This is my x of f spectrum. Okay, x of f. This is my x of f. Yes, this is my x of f. X of f low pass signal, x of f band pass signal. Okay, band pass signal. Now we are going to see what benefit. Okay, so let us first see for this also sampling frequency. What is sampling frequency for band pass signal? Is nothing but sampling frequency for band pass signal is nothing but this is twice of highest frequency divided by what? Factor k. Twice of highest frequency divided by factor k, where this k is nothing but integer. Integer value of what? Integer value of fh minus fl divided by fh. Yes, So this is what this is what fh. So this is what integer. K is nothing but integer value of fh divided by fh minus fl. Okay, fl, or you can say k is equal to integer. K is equal to integer value of fh by bandwidth. Okay, fh by bandwidth. Bandwidth of what? Bandwidth of band pass signal. Band pass signal. Okay, so this is what this value. So now see here, this k factor is always greater than unity. Okay, maximum time in almost cases this k factor is greater than unity. Greater than unity means this band pass, this sampling frequency of band pass signal. This is what band pass signal. Sampling frequency of band pass signal. This is sampling frequency of low pass signal. Low pass signal. Yes. If you see compare, if you compare this what, this is band pass signal. Okay, so band pass signal. If you will compare the band pass, this sampling frequency of band pass, sampling frequency of low pass signal to the sampling frequency of band pass signal. This is sampling frequency of band pass signal is less than sampling frequency of low pass signal. Yes, low pass signal. Sampling frequency of what? Sampling frequency of band pass. Sampling frequency of band pass signal is less than sampling frequency of low pass signal. Low pass signal. Okay, so that is, this is what this conclusion that we get from this. Okay, so from this what we are getting, that sampling frequency of low pass signal is greater than sampling frequency of band pass signal. Then what type of benefit that we get in case of what? Band pass signal. Okay, in band pass signal. So let us see benefit that we get in case of band pass signal compared to low pass signal. See that now we get the conclusion what? Now we know that we know now what? Sampling frequency of what? Sampling frequency of low pass signal. Sampling frequency of low pass signal is greater than sampling frequency of band pass signal. Yes, band pass signal. Sampling frequency of band pass signal. Yes, from here what conclusion we can make? See the conclusion from this. Okay, so this is what conclusion. So this conclusion that we can make here, sampling frequency. See, sampling frequency of low pass signal is greater than sampling frequency of band pass signal. This means what? Number of sample. Yes, number of sample per second. If you see the number of sample per second, number of sample per second that is passing through what? Passing through low pass sampling is what? Greater than band pass sampling. This means what? So this is what related to what? Number of sample passing per second. Here is greater, here is less. Means speed is what? Less. Speed is less. Okay, so we can say what? Speed. We can say about speed. Yes, speed. Speed of what? Speed of, if you see speed of low pass sampling. Low pass sampling. Speed of low pass sampling is what? Is greater than speed of speed of band pass sampling. Yes, speed of band pass sampling. Speed of band pass sampling. Okay, so this is what we can make the conclusion from here. The speed of low pass sampling is greater. Why? Because if you see number of what? Number of sample passing. Okay, number of sample passing per second. Okay, so number of sample that we are taking, in 1 second is larger than band pass sampling. This automatically means this is obvious that the speed of this low pass sampling is greater than the speed of band pass sampling. Yes, this is our first conclusion. Okay, so next is what? Next is about, this is sampling. Next is about what? Sampling time period. If you see sampling time period, then sampling time period of low pass sampling. Okay, low pass sampling is less than sampling time period. Sampling time period of band pass sampling. Band pass sampling means what you are seeing. You are seeing here what? Memory. Yes, so here the memory that contain, yes, memory storage. Okay, memory storage here is what? Memory storage is less. Yes, memory storage is what? Less. You can say from here, increasing the number of digital memory necessary to capture the given interval signal, but here if you see, the memory is less. Yes, memory space is less, means interval. This is what? Storage time. Here storage time is large, here storage time is less, means here number of sample that we are storing is less. Less number of sample. Okay, storage store less number of sample. Yes, storage of less number of sample. Here storage of large number of sample. Yes, here we can store large number of sample. Here here less number of sample. Less number of sample is less number of sample storage. Yes, here you can say large number of sample. Large number of sample storage reduced, means less number of sample, means less number of sample means amount of digital memory is reduced. Okay, that has reduced, for which is necessary for large interval of signal. Okay, so that is necessary to capture the given interval of signal. This is what? Interval. Okay, sampling interval. Here sampling interval is large, so let us say this is what? Sampling interval. This sampling interval is large, means storage is less. If you see here, sampling interval is less means storage is more. Yes, here you see here storage. If you see here, sampling interval is large. Yes, sampling interval large means storage is less. Yes, storage is less. Here sampling interval is small, means what? Here storage is large, means it is storing, but it is storing large number of sample, and it is storing less number of sample. So therefore decreasing the digital memory which is necessary. Okay, it decrease what? It decrease in band pass sampling digital memory. So band pass sampling reduce what? It reduce the digital memory. Yes, it reduce the digital memory storage which is necessary to capture what? To capture the interval of signal. Okay, so that if you see here the sampling interval is less, means large number of sample. So therefore it increase. Yes, it increase the digital memory. Here it increase the digital memory which is necessary to capture the interval of signal. Yes, this is only the difference. If you see here, you are seeing here large number of sample. Yes, large number of sample means sampling interval is very small. Sampling interval small means it is containing large number of sample. Yes, here if you see here, sampling interval is large, means it is containing less number of sample. Yes, less number of sample means what? It is what? It reduce the digital memory. It reduce what? Digital memory which is necessary to capture the interval of signal. Yes, so that's it. Yes. So therefore, for this answer is what? It reduce the speed of analog to digital converter. Yes, A to D converter. So for this answer is, if you see, option A is correct. Option A. Option A is correct because option A that we have seen here. Okay. So speed requirement. Here speed requirement. If here speed is less, yes, speed is less. So it reduce what? It reduce the speed of D to A converter. Yes, it reduce what? Speed of it reduce speed of D to A converter. Reduce speed. Reduce speed of it reduce the speed of A to D converter. A to D converter. it reduces the speed of A to D converter. But here it but here you are seeing here what it is here the this band pass sampling. What is doing this band pass sampling? If you see in case of band pass sampling, it reduce what? It reduce the digital memory. Yes, it is reducing the digital memory because sampling interval is large. Sampling interval large means number of sample that is that that has store is less. Yes, this means what? Digital memory is what? Less means it is reducing the digital memory, which is necessary to capture what? To capture the interval to capture the signal interval. But if we see here, in case of low pass sampling, here the sampling interval is less. Means less means what? Large number of sample is stored. Stored means what? In case of low pass sampling, it increase what? It increase the digital memory. Yes, it increase the digital memory. So digital memory to capture the interval, to capture the signal interval. Yes, signal interval. So but here in answer it is given as large. It increase what? It increase the digital memory. No, it decrease the digital memory. See here, it is decreasing digital memory, less number of sample. So that's why it decrease the digital memory. So answer is this only. It reduce the speed of A to D converter. Okay, so this is all about this benefit of band pass sampling over low pass sampling.